All right, so now what you do is, given an image, right, you use like these multiple scales. These are the same kernels. And this is just showing you like how you change the scale. And this is showing you a standard deviation for that kernel. Right. So if you apply this kernel on this input image, this is the response on the right. Okay. So in a way, what you're doing is you're trying to detect blobs in your input image, or you can say that blobs is a term, but it's trying to detect important or salient regions in your input image. Okay. So this is like one way you can detect interesting points. And you can see, I mean, this is kind of performing edge detection. You know that, I mean, a double derivative actually is a filter used to detect edges, and that's exactly what this is doing. Okay, but let's keep it more generalized and say, okay, these are interesting points. Now you can see that, and again, you have seen this in your first programming assignment. If you change the scale of your kernels, or if you change the standard deviation of your Gaussian filter, then the type of edges you are going to detect that also varies a lot. Okay, so this is exactly showing that. Now, how you extract features from this? Once you have these responses from multiple scales, what you do is you compute like maxima, minima across these scales. Okay, so whatever step I'm going to explain, you will do that for all the pixel locations in all these scales. Okay, if you have 5 different scales, you will perform that operation for all the pixels in these scales. Okay, so let's talk about that step. So this activation map here, if you represent that as, let's say, using this horizontal 2x2 matrix, and if you're interested in this location, the crossover here. So what we do is we look into the neighborhood, right, which is like the surrounding pixels. You will have 8 different pixel values, right, in this feature map. And you also look into activation map from the next scale. Okay, so it's coming from the next scale. And again, you will compute like these, you will consider these 9 values as neighborhood of this pixel location, and again for the bottom. So for this location, what you do is, if the response is actually maximum among all these neighborhood pixel values, you will just store that as a interesting point. Okay, so and you do that for all the pixel locations in all the scales. So what that will give you is, okay, let's say if this is the maximum among all these green dots, you will store the XY location, right? And you will also store S. S is corresponding to the scale. Okay, so if this is 1, 2, 3, 4th scale, you'll just say, okay, the scale is 4. So now what's happening, this way you will detect what are the key points in your input image. And jointly, you are also saying that, okay, this is the key point, and this is the scale of this key point. All right.